Let's take a closer look at the new PIC32 MX1 and MX2. Launched at the end of 2011, the MX1 and MX2 are Microchip's newest 32-bit parts. They are also our smallest and lowest cost PIC32 microcontrollers. They offer great performance with a range of new peripherals and easy to use tools to get you started. Let's take a look inside. Let's take a closer look at the new PIC32 MX1 and MX2. Launched at the end of 2011, the MX1 and MX2 are Microchip's newest 32-bit parts. They are also our smallest and lowest cost PIC32 microcontrollers. They offer great performance with a range of new peripherals and easy to use tools to get you started. Let's take a look inside. The parts are available with a useful 32K of flash and an additional 3K of boot space. Along with this is 8K of RAM. The existing M4K core is clocked to deliver 62 DMIPS of performance from the zero wait state flash. This provides ample performance for data analysis, graphics, audio and to implement communication interfaces. For comms applications, the MX1 and MX2 have 2 UARTs, 2 SPIs and 2 I2C channels. In addition, there is a new I2S interface for connecting to standard codecs. The MX2 parts incorporate a USB controller. Whilst primarily targeted at USB device products, this can also operate in host mode for simple applications. A 1 megasamples per second analog to digital converter allows up to 13 channels to be sampled at 10-bit resolution. The same ADC can be used with a new charge time measurement unit and onboard temperature sensor for a range of applications. Other analog peripherals include 3 analog comparators which can replace existing discrete components. Standard peripherals also include interrupt on change notification for most pins, input event capture and an output compare module that can generate single or multi-shot waveforms along with PWM drive signals. 4 general-purpose DMA channels give a designer the ability to automate many data movement tasks. The DMA controller can be programmed to repeatedly transfer blocks with differing alignments and byte sizes at the source and destination. A pattern match capability allows a transfer to be terminated when a specific word is observed, such as a carried return from a UART or a null byte from a string. Finally, the DMA can automatically generate a cyclic redundancy check as the data is transferred, saving time and space. A range of package sizes provide cost-effective and compact layout options for board designers, and along with the Peripheral Pin Select feature, maximise the use of pins on the selected part. The PIC32 MX1 and 2 are Microchip's lowest cost 32-bit microcontrollers, meaning that the additional flexibility of a 32-bit part is available at prices comparable to some 8 and 16-bit parts. The MX1 and MX2 incorporate several peripherals which are new to our 32-bit lineup. The Charge Time Measurement Unit, or CTMU, Peripheral Pin Select, or PPS, and Inter-IC Sound, or I2S. So let's see how these can operate and what they can be used for. The CTMU peripheral is unique to Microchip and has previously been seen on some of our 8 and 16-bit microcontrollers. It consists of a patented design with a precise programmable current source. This can be started and stopped from a variety of different sources, including input pins, timers, input capture, output compare, analog comparators, and of course software. Once started, a precise charge is supplied from the peripheral into a chosen destination. Typically, this is the ADC capacitor or an external device. When the CTMU is stopped, the accumulated charge then represents time, which can be directly measured. We have found that the uses for the CTMU have been limited only by the imagination of the engineer, but here are some examples. The CTMU can generate and measure precise time intervals of the order of a few nanoseconds, so can be used for TDR and ultrasonic flow measurements. As the CTMU provides a direct measurement of charge, it can be readily used with Microchip's M-Touch technology for capacitive touch measurements through various mediums. Finally, many of the common physical measurements such as resistance, inductance and temperature can be converted into a suitable form for use with the CTMU. The PIC32 MX1 and MX2 are some of the industry's smallest discrete 32-bit microcontrollers. They are available in 28 and 44-pin QFN and TQFP packages, 28-pin SOIC and SSOP, and a new VTLA package provides access to 36 pins in just 5mm by 5mm. Finally, there is a 28-pin skinny PDIP, which provides an interesting option for legacy designs or where wave flow soldering methods are required. With such low pin count packages, it is often necessary to multiplex several functions onto one pin. For instance, you might find that the serial data output would be shared with the UART transmit line or an interrupt pin, preventing their simultaneous use in the same application. The Peripheral Pin Select feature removes this obstacle by providing the option to select different pins depending on need. In the case of a peripheral input, a pin select register is used to assign the input to any one of the RP pins on the device. Similarly, for an output, a peripheral select register is used to define which peripheral output is connected to a pin. This has a number of useful side effects which can be used by the designer. A single input pin can be connected to multiple peripherals, so it could be connected to both a UART receive and also an interrupt on change pin, providing advanced notification of serial activity before the character has even been received. A peripheral output can be connected to a pin and that same pin used as the input to another peripheral, providing the ability to loop back signals for testing. Finally, multiple output pins can be connected in parallel to the same source, allowing a higher drive strength than normally available. The last new peripheral is I2S. This provides up to a 48 kHz stereo data stream that can be fed into standard codecs. Previously seen on our 16-bit DS-PIC DSCs, I2S allows high-quality audio to be directly sampled and played back by the PIC32. Target applications for the MX1 and MX2 include portable music player docks and mixers or karaoke devices that connect to MP3 players. USB connected devices that require some sort of interface to a PC for programming, such as real-time control or data collection, and this typically might be found in power supplies, gadgets and toys. Finally, data collection, such as a pedometer or human interface applications with small displays and the need for capacitive buttons and sliders can also be designed using the PIC32. In summary, the Microchip PIC32 MX1 and MX2 provide a small 32-bit solution to the market. It features some useful and unique peripherals and is available in small and convenient packages, permitting 32-bit performance in new applications.